in triangle ABC, there is a point P somewhere. So I have to keep it away from the center. This is my centroid. So let me keep the point away from centroid P. I think my percentage is less. Let me increase it to 56%. This whiteboard is troubling me. Now, okay, so PA, B, C, PA square plus PB square plus PC square is equal to GA square plus GB square plus GC square minus what? 3PG square, na?
Plus.
Plus 3PG square. Is this 3 there or not?
Yes, sir, it is there.
It is.
Yes, sir, it's there.
Okay. So, of course, we have to find out PA square. Therefore, we have to join. I don't know whether all P with all the segments we have to join. Yes. And maybe G and A need to be joined. And this is median. Therefore, let me join GA. And I don't know. I don't recollect the group, but then I will try. Okay. So, we should first consider triangle PBC because we have Apollonius theorem available there. PB square plus PC square is equal to 2BM square plus PM square. Okay. And now, as far as LHS quantity is concerned, LHS of given quantity is concerned, we have achieved this. We don't have PA square, therefore we should consider a triangle where PA square is available. So triangle PAM. If we apply, not equal to, if we apply Apollonius theorem, then it is PA square plus PM square is equal to, not Apollonius, oh sorry, Stewart theorem, because it is 2:1, na? Sorry.
So in the first equation, it should be 2PM square, na?
2
Yes,
p.m.
sir, 2 p.m. square.
So I am making the mistake. Correct. Okay, so now let us apply Stewart very carefully to triangle PAM. It says AG into PM square plus GM into AP square is equal to AM into PG square plus AG GM L. Just correct me if I'm wrong, because
No, sir, this is correct.
2 years before I must have written this Stewart theorem, so maybe there is some mistake. Is it correct?
Yes, sir.
Yes, sir, it is correct.
Yes.
AM into PG square plus AG into GM into L. Now, to simplify our calculations, let us call GM as small x. Therefore, AG is going to be 2x. Okay. And we are interested in AP square, PA square. Therefore, we divide everything by GM. Okay. So, PA square. Now, these are some skills which you need to develop very quickly. PA square you want, so you have PA square here, plus AG. Now, AG upon GM, I am dividing throughout by GM. So, AG upon GM is 2.
Yes, sir.
pm square, which is equal to am 3x upon gm, that is x, therefore 3. Array, I am avoiding one step, but afterwards don't ask me to write the step in between. You pay proper attention. am upon gm is 3 into pg square plus ag upon ag into gm upon am, out of which gm is cancelled, gone. Therefore we have ag into am. बरोबर चाललंय काय?
Sir, 2 AGM. Sir, 2M, so sorry.
Wait, घर, अरे, wait, make your mic off first. 2 times x plus
So 6x square.
is 3 times x. Very good. So we have pa square plus 2pm square is equal to 3pg square plus 6gm square. X is our gm. Okay, so this is 1, this is 2. You add them. So at least you could achieve LHS. Pa square plus pb square plus pc square plus 2pm square is equal to 2bm square plus 2pm square plus 3pg square plus 6gm square. Is that right? Now this p2pm square to pm square is gone. You anyway wanted 3pg square, which you have already got over here. Therefore that is to prove that 2bm square, sorry, 2 times bm square is equal plus 2 times bm square plus 6 times gm square is equal to ga square plus gb square plus gc square. If we prove this, then our identity is done. अरे हो कि नहीं?
Yes, sir.
No. Okay. So now we have to look at diagram again. Okay. Now we have to apply Apollonius, I think, over here once, because we want GA square is already there, GB square and DC square, all three of them we want. I can write this GM square in terms of GA square.
Sir, yes,
Yes,
sir.
sir. Will
Wait,
be two.
wait. I will do it slowly. I am old compared to you, but hopefully I will do it. 2bm square plus 4gm square. Like gm is equal to x and ag is equal to 2x. So this was 6x square. It's
Sir, 2x into 3x.
ga square plus 2gm. Is it okay?
Yes, sir.
4gm square is ag square and 2gm square remaining, which is equal to ga square plus gb square plus gc square. So ga square gone, and I think this is Apollonius. No? Yes, this is Apollonius. Job done. Apollonius to triangle GBC. The last thing that we require to prove is Apollonius to triangle GBC. Important identity, because we have seen any point in the plane of triangle PA plus PB plus PC minimum, it is Fermat's point. which makes 120 degree with each vertex. Now in 11th you will be asked minimize PA square plus PB square plus PC square. What is going to be the minimum distance PA square plus PB square plus PC square, not distance, identity. In that case, the moment your triangle ABC is fixed, your centroid is fixed, therefore these distances are fixed. You can make LHS minimum by making this term equal to 0. So PA square plus PB square plus PC square minimum when P coincides G. If you take point G as your P, that is centroid. So centroid, this is additional property of centroid, that sum of squares of the distances of the centroid from the vertex is minimum, vertices is minimum. You take any other point in the plane of triangle ABC, PA square plus PB square plus PC square is going to be greater than GA square plus GB square plus GC square. Okay, so this is important to note. And now what you are supposed to prove after this is something OG square, OH square, right?
Yes, sir.
So you should put OH square on the na.
Yes, sir.
So you put P is equal to H. Okay. If you put P is equal to H and simplify, of course you need to do some algebra, then you will get all the answers, hopefully.
Sir, if you put P is equal to O, it's straightforward, sir.
Just a moment. I think P coincides with H and you should get it. If P coincides with O, then OG square you will get, and therefore OH square. I think we should try to it making P coincides with O, what will happen? And P coincides with H, what will happen? Because P coincides with O, then it is 3R square. If P is coincident with O, then LHS is 3R square, and P coincident with O, then it will be is equal to GA square plus GB square plus GC square plus P coincident with O, therefore OG square. Now you will have to really work out what are these terms in terms of small a, small b and small c, because your final identity is in terms of that. So you may do this, try to convert GA square, GB square, GC square in terms of ABC, and OG square can be converted into OH square easily, because we know O, G and H, they are collinear and it is 1:2. So OG square can be converted into OH square easily, no worry here, but you need to convert GA square plus GB square plus GC square in terms of ABC, and you have to apply Apollonius theorem couple of times. Can you do that? I mean, I leave it to you because it is yet a long length calculation which you need to do, and in the remaining time I have to construct triangle ABC using a capital R, small r, R1. Is it part of your,
It will be 3 OG square, right?
it was last year's problem, na? What was,
No, sir.
no?
Sir, mandate.
So,
Tell me what is given now and what am I supposed to construct?
Capital R, small r, R1.
Yes,
and we have to construct triangle ABC.
yes, sir.
Uh,
R1.
sir, here it should be 3 OG square, right?
3 OG square, yes. Okay, capital R, small r, R1.
Schematic.
वेट
So kinetic.
5 मिनिटात मला नाही आलं तर सांगा. विचार करतो, बरेच दिवस केलेलं नाही. I am going to lose my habit of teaching geometry. Next year I am not teaching geometry. R माहिती आहे, R1 माहिती आहे. Auxiliary figure. This is my circumcircle. This is my triangle ABC. This is BC. This is R. This is R1. And this is capital R. This is 2x. R is given, R1 is given. Capital R is given. So I think I can construct R1 minus R upon 2. Dhruva, I think I have solved it. We have a circle of radius capital R. Okay. And at one point, you can construct R1 minus R upon 2, which was distance PQ in Stainer's theorem. R1 minus R upon 2 is a distance. You can construct that segment and you take any radius and construct that segment over here. This is R1 minus R upon 2 and draw perpendicular line to that. That is your BC. Okay. So A is there with you and last year you have solved AR R1.
Yeah. Yes.
Array construction. This one was solved last year. Now I have got you up to BC and you should solve it. Yes or no?